Hey, good morning, folks. How are you doing today? I hope you are enjoying the virtual classroom. I want you to send me your feedback about this classroom and tell me what we can do to improve our teaching and learning. I will appreciate your comments. Feel free, send it to me in my Google Classroom. All right, today we are looking at the molar volume of gases. We are still with the stoichiometry. So today we're going to see how we can convert moles to molar volume of gases. All right. Now, if you don't have this chart, this flow chart, please go ahead and copy this down in your notebook. Molar volume of at STP. I'm going to explain what STP stands for later. If you have mass in grams, you want to get your moles, use your molar mass from the periodic table. If you want to convert from moles to number of particles or number of particles to moles, you use 6.02 times 10 to 23rd power of particles, which is called Avogadro's number. And then here is the molarity, which we're going to talk about in Unit 6. Now, this is what we are going to talk about right now, molar volume. To every mole of a gas, this is the amount of space it occupies, 22.4 liters. All right, copy this chart down in your notebook. So 1 mole of a gas occupies 22.4 liters at STP. What does STP stand for? All right, if you say standard temperature and pressure, you're right. Standard temperature and pressure. Standard temperature is 0 degrees Celsius, which is 273 Kelvin. 180 m or 1 atmosphere is also 1.1 no 1.325 kilopascal or 760 millimeter of mercury. These are the standard temperature and pressure. We'll talk more about this when we get to gas laws. All right, these are the breakdown. Standard volume is 22.4 liters or 22.4 dm3. Standard temperature, of course, I said is 0 degrees Celsius or 273.15 Kelvin. So we're going to see how we can convert Celsius to Kelvin later on in the lesson. But it's a simple calculation. You just add 273 to degree Celsius that you have. Right, one standard pressure is 180 m, which is what we call 1 atmosphere, or 101.325 kilopascal, kPa, or 760 millimeter of mercury, or 760 torr. All these are units of pressures. All right, copy this down in your notebook. Now let's go to first example here, which is the only example anyway. How many liters are in 1.5 moles of oxygen? Now remember, the process, whatever you are given here, comes first. All right? So 1.5 moles is given to us of oxygen, comes first. They make your cheat chart. Remember I said, whatever unit you have here must always be here. So you only have moles of oxygen right here. So what number are you going to put here? And then what are we looking for? We're looking for molar volume. So every mole of a gas, which means it's 1 mole of a gas of oxygen, occupies 22.4 liters. That's all you need to do of oxygen. So the moles of oxygen cross out moles of oxygen. Since you are looking for liters, this is our unit now. So what you need to do is to multiply 1.5 by 22.4. And that will give us 33.6 liters of oxygen. So this is our volume of oxygen that is going to be used. All right, it's as simple as that. And here you go, and that is what we get, 33.6 liters of oxygen. Any question on this? Shoot me an email or send me a message on your Google Classroom. Now this is your ticket at the door. This is the first one we're going to do. So they have 3 questions here. I wanted to solve these 3 problems and send it to my Google Classroom. And in the Google Classroom, you see where at the top you see a classwork. That's where you click and then you upload your answer key, or you can even type it in your document and I will see it and share with me. Alright, the second section we're going to have today is the 3-step calculations, of 3 or 4-step calculation, which is mass to mass. Mass to mass. They are the same process, you just need to be careful. Make sure you write your unit. Let's go. And this first example. How many grams of calcium nitride are produced when 2 grams of calcium react with an excess of nitrogen? And this is the equation given to you. Remember, the first thing to do is to balance your equation. Balance your equation. Alright, I have the equation right here. Calcium, nitrogen to give calcium nitride. I have 1 calcium here, I have 3 calcium here. So in order to balance that, put my 3 right here. So I have 3 calcium, 3 calcium. Then I have 2 nitrogen, 2 nitrogen. So the mole ratio here is 1 and 1. And remember, we're given 2.00 grams of calcium. Alright, make a T chart. What are we going to put here? Grams of calcium. And once you see the grams of calcium, what comes to your mind? Periodic table. So what is the mass of calcium? That will be 40 grams. Alright? Because you have grams here. And this is 1 mole of calcium, right? That's the step 1. Now, the next step, this is calcium. Always put your unit. Grams, calcium, grams of calcium, cancel grams of calcium. The next step is, this is mole of calcium. Mole of calcium comes right here. What are we looking for? We're looking for calcium nitride. So that means moles of calcium nitride will be at the top right here. Okay, now there's a blank here. This is your mole ratio section. This is your mass section. You start with the mass, we're going to end with the mass. So we're still going to have 1 more step here. So what to do now is to look at the mole ratio of calcium. On the balance equation, the mole ratio of calcium is 3. So that 3 goes right here. Alright? What is the mole ratio of calcium nitride? It is 1. That 1 goes here. So this section is your mole ratio. Now the mole of calcium cancel the mole of calcium. You see the way I'm cancelling the unit now? Alright, the next step is the grams. You started with the grams, we're going to end with the grams, which is mass. So we have mole of calcium nitride here. It's going to be 1 mole. Remember, it's always 1 mole at the end. There's always 1 mole at the end. So what you do now is to calculate the molar mass of calcium. Right, calcium is 40, and you have 3 of that. Calcium, that's times 3, that's 120. Nitrogen is 14 times 2. We have 2 of nitrogen, and that will be 28. So the answer is 148. So you have 148 grams of calcium nitride here. Alright? Any question on this? Just look at it again. 2 grams is what we are given. Grams of calcium, grams of calcium. Now, to get the grams of calcium here, you look at your periodic table, which is 40 grams. And this is 1 mole. Anytime you look for mass of a substance, it's always 1 mole of that substance you're looking for. So that 1 mole comes to the top here, right? Okay. Now, the grams of calcium cancel grams of calcium. Because you have 1 mole at the top here, mole of calcium will be at the mole of calcium at the bottom. So top and bottom will be able to cancel out. And then whatever you're looking for is always at the top. That is your calcium nitride from the question. Okay, so since you have mole of calcium nitrate at the top, mole of calcium at the bottom, and this section is your mole ratio, you now go back to your balance equation. 3 moles of calcium right here, 1 mole of calcium nitrate right here. The moles of calcium nitrate also cancel moles of calcium nitrate because the moles are the top and bottom. So anytime you're looking for mass, remember, just like here, you look for mass of calcium, it was 1 mole at the top. You look for mass of calcium nitrate to be 1 mole at the bottom. That's how it works. Just follow the rules and you have no problem with that. Alright? So the next step is to now multiply the top. 2 times 1 times 1 times 148. Write it down. And that will be 148 times 2. That will be 16. And that will be 8, 9, 298. So you have 298 here. So it's equals to 298. Divide by 40 times 3, 120. This will give us 2.5 grams of calcium nitrate. And this will be the amount of calcium nitrate produced. So that means if you started with 2 grams of calcium, we are going to get 2.5 grams of calcium nitrate. So 2 grams of calcium will produce 2.5 grams of calcium nitrate. So this is your mass to mass or grams to grams. It's as simple as that. And this is how we arrive at this very table. So that the grams of calcium cancel grams of calcium, mole of calcium cancel mole of calcium, mole of calcium nitrate cancel mole of calcium nitrate. So multiply the top, 2 times 1 times 1 times 148, divide by 40 times 3, which is 120. So everything will be 2.5 grams of calcium nitrate. Right? Second example. I want you to solve this. Pause the video and solve it on your own. This is already balanced for you. So after you finish, you will get something like this. At the end of it, you have nitrogen cancel nitrogen grams, 1 mole of nitrogen cancel 1 mole of nitrogen, 2 moles of ammonia cancel 2 moles of ammonia, because look at the 2 grams of nitrogen with excess hydrogen. Just ignore that word excess. We are coming to that. So we have 2 grams of nitrogen. Then you ended up with getting 2.4 grams of ammonia. Ammonia is Na3. So when you start with 2 grams of nitrogen, you end up with 2.4 grams of ammonia. Please pause the video and go over it once again. If you have any problem or any concern, just let me know. Alright? Alright folks, this is your ticket at the door. So this is the second ticket at the door that you have to send to me today. That means you have 8 questions. 3 questions from molar volumes and 5 questions from grams to grams. Remember to balance your equation first before you can move on to the calculation. Alright? I'll see you tomorrow. Enjoy your day. Take care. Bye. Love you guys. Keep on working and be safe.